This question you asked in gate 23 of instrumentation. This is from, you can say either from signal system or from control system subjects. Okay. The question is, a system has transfer function y of s by x of s is equals to s minus pi by s plus pi. Let ut be the unit step function. The input x of t that results in a steady state output yt equal to sin pi t is dash. So you are given with these options. So this is a very general model question, students. So we are having the sinusoidal output here. The only difference in the previous questions and this question is, in the all previous question, transfer function and input used to be given, we used to find the output. But in this case, transfer function output is given, we are supposed to find the corresponding inputs. So not a big deal. So what we do is, so let us first try to find what is the corresponding transfer function magnitude and phase at the input frequency, and we know input frequency is same as the output frequency. So because output frequency is pi here, you can see in all the options the frequency is pi. Nowhere it is something else. It has to be pi because it's a LTI system. By default we assume that. So the frequency response function, which is y of j omega divided by x of j omega, is equals to j omega minus pi divided by j omega plus pi. So this is nothing but your h of j omega, we say. So what is h of j omega magnitudes? H of j omega magnitude, if I ask you, so it is square root of omega square plus minus pi square divided by again square root of omega square plus pi square. So this and this cancel out, you get this answer as 1. So this magnitude is 1. And what about the phase? So phase, if we try to calculate what is h of j omega phase, so you can see here, so this is coming in the second quadrant. So that's why you get this is 180 degree minus tan inverse of how much? Tan inverse of omega by pi, right? Omega by pi. And for this denominator term, you get tan inverse omega by pi, because this is in denominator, you get a negative sign. So minus tan inverse of omega by pi. So if you check it out, so this is coming as 180 degree minus 2 tan inverse of omega by pi. This is nothing but your phase. But we have to find this phase at the frequency. What frequency? Either the input frequency or the output frequency. That means, I want to find what is h of j pi. So I have to substitute omega equals to pi. 180 degree minus 2 tan inverse of pi by pi. So pi by b is 1. Tan inverse of 1 is 45 degree. So 2 into 45 degree, 90 degree. 180 degree minus how much? This is coming as 90 degree. Are you getting or not? Because 180 degree minus 2 into tan inverse of 1, which is 180 degree minus 2 into tan inverse of 1 is how much? 90 degree. Sorry, 45 degree, right? 45 degree. So 180 minus 90. So this happens to be 90 degree. Okay. So it means that my h of j pi, okay, so this magnitude is 1 and its corresponding phase is 90 degree. Now, what is the standard pattern, how it happens? So you know, like the input is a sine of omega t plus phi. If this is what is the inputs and it is given to a system whose frequency response is h of j omega, we get the output as a multiplied by h of j omega magnitude sine of omega t plus phi plus phase of h of j omega. And this omega here, what I am writing, this is nothing but the corresponding signal frequency, what is given in the inputs. So now this is given to us, students, and this is given, we are supposed to find this. So the magnitude is 1 and I am not evaluating this magnitude, like in the phase case, I have substituted omega equals to pi, I have evaluated. It is not required here because this is 1 for all frequency. Okay, whether it is pi or it is not pi, for all frequency it is 1. So you know magnitude is 1 for all frequency. So at pi it is also 1 and the phase is nothing but your 90 degree. So now you have to think, like this is given that the output is given how much? The output is given sin pi t. So sin pi t is given. This is what is your sin pi t is given. Now you imagine what should be present here so that you get sin pi t, provided the magnitude is 1 and the phase is plus 90 degree. Plus 90 degree is nothing but your pi by 2 in radian if I write. So the transfer function is magnitude is 1 and phase is pi by 2, and the output is 1 sine pi t. So what should be the input? So definitely the input should be sine pi t minus pi by 2. This should be the input, because if this is the input, so if this phase will be added here, so this minus pi by 2 plus pi will cancel out, so it will be left with only sine pi t. And magnitude, if this magnitude is 1 and this is 1, so 1 into 1 it will be 1. So naturally this should be your answer, sine pi t minus pi by 2. Sine pi t minus pi by 2 is given option C, that's the right answer. And because all these these things are happening for t greater than 0, that's why ut is attached here. So if you can write this is applicable for t greater than 0, or you can multiply ut here, just to indicate that these datas which are all happening for t greater than 0. So answer has to be C, right? So you should have this idea. This is very standard model problem in the GATE exam. So we have evaluated the magnitude and phase of the transfer function at the signal frequency, and by observing the output and this one, we figured out what should be the inputs. So that if this pi by 2 will be added here, so that this will be cancelled, we will be getting sine pi t. Magnitude is not changing, so it has to be same, sine pi t. So answer is option C for this. This question is asked in GATE 23 of instrumentation. This is from signal system subjects and from fundamental of signal topic, we can say. The question is, consider the discrete time signal x of n, where un is 1 for n greater than equal to 0 and 0 for n less than 0. The smaller n for which xn equals to 0 is how much? Okay. So basically we have to draw the waveform, and we have to tell like for what value of n xn is 0, what is that minimum value of n? Okay. So how does this u of minus n plus 5 will look like? Okay. So u of minus n plus 5. So okay, so let me write here u of minus n plus 5. So this will be existing for what range? So this will be existing as 1 for n less than equals to 5, and this is 0 for n greater than equal to 6. N greater than 5 or n greater than equal to 6. Because how I'm getting it, either the scaling shifting, you can do that way. Otherwise, by definition also, if you go it, so if you see this, the definition, like whenever this inside bracket term is greater than equal to 0, you get 1. So I can say here, so whenever minus n plus 5 is greater than equal to 0, I get 1. So minus n is greater than equals to minus 5, or n less than equals to 5. If I multiply negative side, the equality will be changed. So for n less than equals to 5, it is 1. For rest of the range, it is 0. So rest of the range means either n greater than 6, or either you write n greater than 5, or you write n greater than equal to 6. Okay. So u of minus n plus 5, this is the description. Similarly, what about u of n plus 3? U of n plus 3, where it start? It start at minus 3. So this is 1 for n greater than equals to minus 3, and this is 0 for n less than equals to minus 4, or n less than minus 3. So now let us plot it. So u of minus n plus 5, if I plot, so how does it look like? So let's say this is your minus 5, then this is your minus 4, this is your minus 3, this is your minus 2, this is your minus 1, this is 0, 1, 2, 3, 4, 5, right? So for n less than equals to 5, it will be 1. So these are 1 like this forever, and beyond it, I mean for greater than equal to 6, this is 6, this is 7. So here the amplitude is 0. This is 8, the amplitude is 0. So this is what? This is the waveform of u of minus n plus 5. Now I have to plot u of n plus 3. U of n plus 3, if I want to plot, so it will be existing from to the right of minus 3. So minus 3 is this one. So minus 3 here. So these all values, so they are 1. This is 1. This is minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is the waveform of u of minus n plus 3. And to the left of it, this is 0. So that is, here it is 0, here it is 0. So this is minus 4 and this is minus 5. So I have to subtract this waveform from this. So now if I ask you to subtract it, okay, 1 second. Yeah. So let us take the range. This is minus 5. Then you have minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Actually, no need to draw the waveform. If you can visualize the way question is framed, you can directly answer by visualizing this waveform in your mind also if your fundamentals are good. Okay, now if I am subtracting, now what is going to happen, students? If you see this, from minus 3 to 5, both of the waveforms are 1. From minus 3 to 5, both of the waveforms are 1. So 1 minus 1 is, you're definitely 0 only. Okay, and what is going to happen to this left of minus 3? So to the left of minus 3, I mean from minus 4 onwards, I mean from these segments. So this waveform is 1 forever and this waveform is 0 forever. I mean, I'm asking from minus 4 to minus infinite. This is constantly 1 and this is constantly 0. So 1 minus 0 is 1. So that means I can tell, so this is constantly 1 up to minus 4. So this is constantly 1 up to minus 4. So this is 1 forever. I mean from minus 4 to minus infinite. Then from minus 3, okay, up to 5. So minus 3 to 5. So this minus 3 to 5, I mean this entire segment, you see both signal amplitudes are 1. This is 1 and this is 1. 1 minus 1 is 0. So I can say 0, 0, 0, 0, 0, 0, 0, 0 and 0. Minus 3 to 5, it is all 0. Then 6, 7, 8. What is going to happen? 6, 7, 8. So I mean beyond 5. So this is constantly 0 forever and this is constantly 1 forever. So 0 minus 1 is minus 1. That means, so this is your minus 1, this is your minus 1 and this is your minus 1. So this is minus 1 forever. So this is what the waveform x of n is. So what they're asking, so x of the smaller n for which x of n is 0. So x of n is 0 in this range. So what is the smaller value of n? So the smaller value of n is definitely your minus 3. Because xn is 0 in the range of minus 3 to 5. So among this, which is the smaller one? Smaller one is definitely your minus 3. So your answer has to be minus 3 in this case. Okay, so very simple. You draw the waveform u of minus n plus 5 and u of this n plus 3, and by drawing it corresponding waveform, we can see, we can visualize the complete waveform. It is 1 from minus infinite to minus 4. It is 0 from minus 3 to 5. It is minus 1 from 6 to plus infinite. So it is 0 in the range of minus 3 to 5. The smallest value of n among this range is minus 3. So answer has to be minus 3. Okay. So very simple questions. This question is asked in gate 23 of instrumentation. This is from signal system subjects and from classification of signal topic. The question is, let yt equals to x of 4t, where xt is a continuous time periodic signal with fundamental period of 100 seconds. The fundamental period of yt is how much? Okay. So we can directly say, student, the answer here it will be 100 by the scaling factor 4, it will be 25 seconds. How is it happening in the sense is, now imagine you have a periodic waveform like this. Let's say you have a periodic waveform. Okay. So like this, you have the periodic waveform. So this is 0, this is 100, this is 200, this is 300, this is minus 100, and so on and so forth. Because periodic signal means it will exist from minus infinite to plus infinite. So this is the waveform x of t. Now if I ask you to draw x of 4t, so what is going to happen then? In every time index, you will be dividing the scaling factor 4. So 0 by 4 is 0, 100 by 4 is 25, 200 by 4 is 50, then it will be 75, this will be minus 25, and so on and so forth. So now naturally the period will be this one only, this gap, which is 25 seconds. So very simple, right? In the time scaling, the periodic signal, its corresponding waveform, the period it reduced by the scaling factor. So here the scaling factor is 4, so original period is 100 by 4 is 25. And how is it happening? You can take any example and you can see it clearly. So answer is 25 for this. This question is asked in gate 23 of instrumentation. This is, you can say, either from signal system or control system. The question is the impulse response of an LTA system h of t is delta t plus 0.5 delta t minus 4, where delta t is continuous time unit impulse signal. If the input signal x of t is 7 pi by 4 t, what is the output? Okay. So what we do is, so here what is the data given? The data given is, we are having a system like this, and its corresponding impulse response is given, which is your h of t, and the input signal is given, which is your x of t, and we are supposed to find what is y of t. So what we're doing is, students, so we'll be first finding what is the corresponding frequency response function h of j omega and its corresponding magnitude and phase at the input signal frequency. So the input here is cos of 7 pi by 4 t. Okay, so the output here it will be, because the frequency is 7 pi by 4, so h of j 7 pi by 4, h of j 7 pi by 4, this magnitudes multiplied by existing signal magnitude is 1. So then you have the cos function. So cos of 7 pi by 4t plus h of j 7 pi by 4, this phase. I mean, this is what is the output you will get. So if the input is sinusoid, output is sinusoid. The change is you have to multiply the frequency response magnitudes and you have to add the frequency response phase. So you have to evaluate these frequency response functions, magnitude and phase at the input signal frequency. So the magnitude you multiply with the input signal and the phase you add. That is what your output is. So first thing is, we don't have the h of j omega information directly. The time domain data is given. So let us find its Fourier transform to get this h of j omega, and then I will be substituting this 7 pi by 4 in place of omega, and we will find the magnitude and phase. So here the h of t is given as how much? Delta t plus 0.5 delta of t minus 4. So if I ask you to take the Fourier transform delta t is 1. Fourier transform of delta of t minus 4, it will be e raised to power minus j 4 omega. Yes or no? So now if I expand it, so I get this is 1 plus 0.5 cos of 4 omega minus 0.5 sine of 4 omega. But here you have a j sine, because e raised to power j theta is cos theta plus j sine theta. So 0.5 cos 4 omega minus j 0.5 sine 4 omega. So now what we'll be doing is, so let us substitute the value of omega. So what is the omega? 7 pi by 4. So if I ask you what is h of j 7 pi by 4, so what you get? You get it is 1 plus 0.5 cos of 4, and this is 7 pi by 4 plus minus j 0.5 sine of 4 into 7 pi by 4. So this is 1 plus, so 4 cancel, it is cos 7 pi minus j 0.5, and this is 4 cancel, you get it is sine 7 pi. So here we have a factor 0.5, students, actually, 1 second. It is 1 plus 0.5 cos 7 pi and then minus j 0.5 sine 7 pi. So this factor is 0. So you have cos 7 pi. So 1 plus 0.5 into minus 1 to the power 7. Cos n pi is minus 1 to the power n. So this is 1 plus 0.5 into minus 1. So if you evaluate what is this 0.1, so this is coming as how much? 1 minus 0.5, so that happens to be 0.5. So it's a real number we are getting. So I mean, in other words, its phase is 0, so it is 0.5 at an angle of 0. So 0.5 at an angle of 0. So h of j 7 pi by 4. So I mean that the magnitude, so this quantity is coming as 0.5 and this quantity is coming as 0. If I write it, the answer will be 0.5 cos of 7 pi by 4t. So this is what your output will be, 0.5 cos 7 pi by 4t. So if you see, that is given in option A. So A is the right answer for this problem. It's again, students, Very normal repetitive model question in the GATE exam. Answer is option A for this. This question is asked in GATE 23 of instrumentation. This is from signal system subjects and from Laplace transform topic. The question is the Laplace transform of the continuous time signal x of t is e raised to power minus 3t u of t minus 5. Where ut denotes the continuous time step signal. So we are supposed to find the Laplace transform of this function, right? So along with the ROC, we know that e raised to power minus 3t ut. If I ask you what is the Laplace transform, it will be 1 by s plus 3 and sigma greater than minus 3, sigma greater than pole location. Then because we have the shifting factors, so let us introduce the shifting. So we cannot introduce the shifting in a selective part of the signal. The entire signal has to be shifted. So if I am replacing t by t minus 5 in the entire signal, I have to multiply e raised to power minus 5s. So by s plus 3. This is applicable for again sigma greater than minus 3 because time shifting property doesn't have any role on the ROC. So the entire signal is shifted by 5 t replaced t minus 5 e raised to power minus 5 plus I have to multiply. But we are supposed to find the Laplace of this one. I mean, you don't have shifting on this factor. So I can write it is e raised to power minus 3t and this is u of t minus 5. So what is the factor here? E raised to power plus 15. E raised to power minus 3 and e raised to minus 5 is e raised to power plus 15. So this if you take it to other side, or I can write here e raised to power plus 15. So this is e raised to power minus 5s divided by s plus 3 applicable for sigma greater than minus 3. So now you can easily you can visualize here. So now what you have to do, so e raised to power minus 3t u of t minus 5. So you have to find for this, right? So now if you bring this 15 this side and if you write it, so it is e raised to power, if you take minus 5 as common, it is s plus 3 divided by s plus 3 valid for sigma greater than minus 3. Because if you bring this 15 to this side, you get here e raised to power minus 15. And e raised to power minus 15 we are expecting, you can see here, if I take minus 5, you will get plus 3. So that is equivalent to e raised to power minus 5s into e raised to power minus 15, which is equivalent to e raised to power minus 5s plus 3. So this is what is the answer, students. So this is what is given one of the option, that should be the right answer. Where it is given? E raised to power minus 5s plus 3. Okay, I think option C. Right? So sigma is nothing but a real part of s. So yeah, we can see this. Answer is option C for this. This question is asked in GATE 23 of instrumentation. This is from signal system subjects and from city of the topic. The question is a continuous real valued signal x of t has finite positive energy and x of t is 0 for for all time which is less than 0. From the list given below, select all the signal whose city ft is purely imaginary. So this question is based on the symmetry condition, students, right? So certain data from the symmetry condition, so I'd like to give here. So this x of t plus x of minus t, students, okay? I mean option wise, let us go. X of t plus x of minus t. So because x of t is real, so this is nothing but, this signal is nothing but real and definitely even, because x of t plus x of minus t always indicates an even signal. X of t minus x of minus t always indicates an odd signal. So because the original signal is real, the overall signal is real, and because of x of t added with its x of minus t, so it is definitely even. So a real and even function, its corresponding CTFT is again real and even. This is a standard property. Now coming to option B, x of t minus x of minus t. So this is again, student, you can see this is again real, but x of t minus x of minus t, so it is definitely odd. So real and odd have Fourier transform your imaginary and odd. So this is again based on the symmetry condition. Now coming to option C, it is j multiplied by x of t plus x of minus t. So if you see, if you compare this and this, so this is even. I mean this is real and even. Now in this j is multiplied. So what is the now change? Now the thing, it is definitely your imaginary and even. So because it is indicating a even function even, and because j is multiplied, it is your imaginary. So imaginary and even, its Fourier transform is again imaginary and even. So based on the symmetry property. Now lastly, j multiplied by x of t minus x of minus t. So because of the j term, it is purely imaginary, and x of t minus x of minus, this is odd, right? So imaginary and odd have Fourier transform real and odd, again based on the symmetry property. What you're supposed to find? Select all the signal whose CTFT is purely imaginary. So purely imaginary means this and this. So this and this means B and C. So these are two functions whose Fourier transform will be purely imaginary, and it's a MSQ question, right? So answer has to be option B and C. Okay, standard symmetry property based question.